On 32, we're asked to graph this rational function. So to do that, let's first find the vertical asymptote. We would set the denominator equal to 0. And setting it equal to 0, you would then factor, and we would end up with x minus 3 times x plus 1, which would give me x is 3 and x is negative 1. So these become my two vertical asymptotes. You'd want to write those as equations of lines. That would also determine that the domain would be all the real numbers except for those two x values. So my domain would be negative infinity to negative 1, negative 1 to 3, and 3 to infinity. To find the horizontal asymptote, we compare the degree of the numerator with the degree of the denominator. Since they're the same, we'll use the leading coefficients of those two terms, which would be y equals 2 over 1 or y equals 2. To find the x-intercept, we let the numerator equal 0, which is letting y equal 0. So if 0 equals 2x squared minus 1, 1 is 2x squared. Use the square root property. Don't forget that that would give me both a plus or a minus, square root of 1 over 2. So that's plus or minus 1 over the square root of 2, which needs to be rationalized. And when I rationalize that answer, I would end up multiplying the numerator and denominator by the square root of 2. So plus or minus square root of 2 over 2, 0, which in decimal form is 0.070, 0.707 and negative 0.707. Next, we'll find the y-intercept. In that case, let x equal 0, and we'll have y equals 1/3, so the point 0, 1/3. Now I'm going to use my calculator as a guide on this problem. I've plotted the x-intercept, I've plotted the y-intercepts, I've also drawn in my asymptotes. And then I do notice that this, either using the tables or by plugging in x values to the left of that vertical asymptote, I see that this one actually dips below the horizontal asymptote. If you want to find this intersection point, you could actually type in y equals 2 as your second equation and find the intersection between them. In that case, you'd get a negative 1.25, 2 as the point of intersection. I plugged in x values, looked at my table on my calculator, and filled in a couple more points to actually complete that graph. And then I did the same thing for the right branch. I looked at x equals 4, 5, and 6 and found those accompanying y values.